Right.
So this question here, it starts off by giving you some information, and then we have to try and figure out an equation that we could use to solve it, right? So we want to, basically, you need to identify what you're being trying to find. Now, right at the end of the sentence, they give me a clue for what I need to find. I need to find out how many people are in the family, okay?
Mm-hmm.
So I'm just going to write down, and you'll see this in a minute, X equals number of people in the family. But I'm now going to kind of show you on the notes, and I'll just read what was on the screen. It's kind of hard to do both at the same time. I can only do one. So what we told here, the admission charge for a family at a zoo is $5.50 for the first person. So the first person, they're going to get charged $5.50. And then every additional person, right? The next person and the one after that and the one after that. So I'll just call them the rest. The rest of the people, they are going to get charged $4.25 each. And I'm also told that the total cost of all the tickets came to $18.25. That's essentially everything that we need to know.
Mm-hmm.
Let's figure out how to get an equation with X. So I'm going to take that piece of information and see if there's another way to calculate. So if I was being asked to find the total cost, well, it would be $5.50 plus the number of the rest. How many of these people there, right?
Mm-hmm.
Times $4.25. So it's $5.50 for the first person plus $4.25. Now, if you want to know how many people do the rest count, you might want to set up a little pretend situation and see if we can see a pattern, right? For instance, if X was 5, if there were 5 people, that would be one person at $5.50, and the rest would be 4, and they would be at $4.25. And if you wanted to get the total, it would be £5.50, $5.50, I should say, times 4 of these guys. And then I'll pick another random number. Suppose there was 10. How would we do that? Well, you'd have one person would have to pay $5.50, and the rest would be 9. And they would be at $4.25. And the total cost would be $5.50 plus 9 times $4.25.
Mm-hmm.
And now I'm going to say X is just X. In other words, I'm not going to make a number. It's not going to be 5 or 10. I'm just going to call it X. And what would that look like? Well, one person would get charged at $5.50. And let's see what the other number is. Well, when X is 5, the rest was 4. Right? So if you had 5 people, the rest was 4. If you had 10 people, wouldn't the rest be 9, right? 1 plus the rest.
Mm-hmm.
Right, if there was 1 million people, you'd get 1 and 989,000 thing, right? If there was 7 people, if X was 7, you get 1 of these and 6 of them. Now, X, you're going to get 1 of them. What does the rest look like? That's the trick. Once we can get what this is in terms of X, we are ready to come up with this formula here. What do you know about this number? Isn't it always 1 less than that number?
Mm-hmm.
So 5 gets you 4, 10 gets you 9, 20 gets you 19, 100 gets you 99, X gets you. How do you write 1 less than something? 1 less than x. Well, you write it as x minus 1. And that's algebra. That's how we that guy there represent an unknown number. For instance, if I went back to this question, I could have said 4 was 5 take away 1. I could have said that rest. Well, that was 10 take away 1. Right, this guy here, right? Isn't that basically x take away 1? You see, it's the same pattern. Right, we got the formula. And our formula is that it's $5.50 plus 4 times the rest. And I've got that wrong. It's $4.25 times the rest. And that's going to be x minus 1. So I'm just rewriting this again because it's kind of messy. That's what the first person pays. And that's what all the other people pay, the rest.
Mm-hmm.
And there's x minus 1 of them. So that's the total cost. And now I'm going to bring this into the mix. Oh, you told me that it came to $18.25. So now I have what we call an equation, right? It's something equals something else, and there's an x in it, and we are trying to find, x.
Mm-hmm.
Well, let's keep going then. If you want to solve an equation, even one with ugly decimals, you still follow the same basic rules. First thing I would do,
You
would be to
distribute 4.25 into x, right? And then into 1.
Yep, you're ahead of me. Yes. What would I do next?
Then you're going to combine like terms.
Okay, so that guy and that guy's a number. So if I combine them, I get what, $1.25,
Mm-hmm.
and I get $4.25 times that. Got to be careful. My decimal points get a little bit big and ugly when I'm not careful. So combine these terms, and you get $1.25. Right. What should I do next?
Subtract 125 from both sides,
Which I believe is a nice number, 17. And we're almost here, aren't we? What should I do now to both sides?
divide 425x by both sides.
Okay, so I'll do that on the calculator because it's kind of messy. And with a bit of luck, a nice number. Whoa, that is a nice number, isn't it? It's 4.
Mm-hmm.
And we have just found that the number of people in the family, x, is 4. I'll go back and put that thing in. Give it a check in case there's something I need to adjust. And it tells me I was right. So it was 4 people. So what we're trying to do when we do these puzzles is do what you would have done if everybody had been numbers. But one of the pieces typically is not going to be a 42 or a 4. It's going to be an x or an x minus 1. And we have to figure out some way to incorporate that into our story. So that was the only application in that section. If I now move on to chapter 2, which is basically nothing but applications, we'll get to see lots of different situations.
And that's the only part of the homework that I struggled with, was the applications.
Okay, then let's go for that one. I'll show you the question that we have, and then we'll try and construct it, because what we're trying to do here is put a whole load of information that we're given and use it to solve a puzzle. I've got a whole load of, it keeps doing answers, which is a real annoying thing because that distracts everyone. Right, okay. A coffee merchant combines coffee costing $4 a pound with coffee costing $3.50 a pound. And we are trying to find how many pounds of each should be used. So the question is, how many pounds of each kind of coffee should be used? And we have to do it so that we make 30 pounds costing $3.80 a pound. So there's a lot going on here. So I'm going to take each piece and kind of break it down. The first kind of thing is that we're being asked to find how much of each kind of coffee. So there's going to be two kinds of coffee. I'm just going to call them A and B to make it easy reference. Coffee A is going to cost $4 per pound. And this second coffee is going to cost us a little bit less, $3.50 per pound. Now, when I read a little bit later, they tell me that you make a total of 30 pounds of coffee. So that was one of the pieces of information they gave me. Now I'm going to use it to start putting X's in. Now, I don't know how much of that coffee, right? I'm trying to find it out. I'm going to call that X, right? If you don't know something, call it X. Now, I know that that guy plus that guy comes to 30 pounds. So I want to find out what this thing is also using X's. That's the trick, to have X's here and to have here. Well, if the total is 30 and that is X, what will this be in terms of a number and an X?
X plus 30.
Well, there's an X and a 30, but not that way. So let's do some numbers and that may give us a help. Suppose A was 10 pounds. What would B be? Right, together they make 30. So if A was 10, what would B?
20.
20, right? Suppose it was only 5 pounds of this stuff. How much would B be?
B would be 2.5.
2.5 or 25?
Oh, 25, because they all have to equal.
They're all whole numbers, right? Suppose this was 15 pounds. The colours have no significance. If this was 15 pounds, how much would the other one be? Remember that together they add up to 30 pounds every time.
It'd be 15 pounds.
Now, there is a direct connection, isn't there, between what this guy is equal to and that guy?
Mm-hmm.
And it's not that you take this number and add 30 to get that one. Do you notice that that wouldn't work?
Mm-hmm.
I mean, this guy plus that guy gets you 30. I agree with that, right? Oh, that's an idea. I don't know what this guy is, so I'm just going to call him question mark for a minute, right? And I'm going to say X plus 20. What's it? The number there. X plus unknown is 30. Then won't X be 30? Take away the unknown. Do you see that guy?
Mm-hmm.
And won't the unknown be 30? Take away X, right? You could write it either way, right? That's now told me who this guy is. Whatever this guy is, this is 30, take away that. That's kind of what my brain is doing that in my head. I'm not sure writing it down was helpful, but it helped me. Right, if this is X, this is 30 minus X. Do a check on that. What do you get if you add 30 minus X to X? Don't the X's cancel out and the total is 30?
Mm-hmm.
You see how that works now?
Mm-hmm.
Right, so we have set up the beginning of the problem. We now have an X for the two things we're trying to get. So I'll rewrite this guy because there's a lot of things getting written down here. The cost of $4 per pound is going to be called X. And the other coffee B, which costs $3.50 per pound, is going to be called 30 takeaway X. So I can now tell you what the total cost is going to be of all the coffee. So the total cost of all 30 pounds, it's going to be X pounds at $4, so that's 4X. And it's going to be 30 minus X at that price, so that's going to be 3.50 if you like, 30 take away X. Are you comfortable about where this came from now that I have an X and a 30 minus X, or how much of each kind of coffee I'm going to use? Right, $4 X, $3.50, 30 minus X. That's the total cost of all the coffee, all 30 pounds.
So the unknown, so B the B is the 350 times 30 minus X.
Yeah.
Because so if there's 30 pounds of coffee total,
Mm-hmm.
then if you subtract 30 from X, wouldn't that? Oh wait, no, I understand now.
Right. If you combine them, that is £30, right? That guy and that guy makes 30. It's just split into two pieces.
Right.
$4 and $3.50.
Say if X was 10,
Yeah,
then the amount of B coffee would be 20 pounds.
correct.
Okay, I get it.
Now, to have a real equation, don't I need to know a number here as well?
Mm-hmm.
And it would have been really nice if the question had told us the total cost of all £30 is $400 or $82 or something. But they didn't tell me that. They told me that the £30 that you end up making come out at an average of $3.80 per pound. Now, this represents the total amount in £30. I want to find out the total amount of this. Well, it's £30 multiplied by $3.80. So in fact, that number that we should have been using is $114. Are you happy about where that 114 came from?
Yeah, because you took the total amount of coffee and the average price per pound and multiplied it. That's the total value.
Right. Now we're finished the hard part. And the hard part is always going to be create this equation, right?
Mm-hmm.
And we're just going to go through the typical steps, right? But let's finish it because it's good practice. What do you think should be the first piece of algebra I should do next to this equation?
Distribute 350 into the 30 minus X.
Right. Too hard for me to risk in my brain, especially this time of day. So 3.5 times 30, that's 105. And 3.5, that just gets me, I'll call it 3.5. Who needs a zero, right? 3.5x. And this here is 114. Okay, what do we do next?
We'll combine like terms that'll give us 1.5x. Or 0.5x.
Mm-hmm. Yeah, I know what you meant, right? What will we do next?
Subtract 105 by both sides.
Oh, God, that's a hard one. 9. Okay.
And then divide 1/2 by 9.
Yeah, and you end up 18, but you can do it in your calculator to check, right? Now, we've solved the problem. Let's just go back. The $4 a pound coffee was X, so that means £18, right, of that coffee.
Mm-hmm.
How much of the other coffee, the cheaper $3.50, do you need?
12 pounds.
And those are the two numbers that go in the box when it asks you to give the solution.
Mm-hmm.
And that's the end of the coffee one.
Okay.
Okay. Now, once you've seen question 1, there's a couple of other questions that may have a different storyline, but they're really, in a lot of ways, very similar, right? Mm-hmm. They might not talk about coffee. For instance, are you looking at question 2 right now?
I was looking at, I think I got question 2. I know.
Okay, which is the next one you're having trouble with? Let's go to some that's worth your time.
Question 3.
Okay, so we're on question 3, and in question 3, it's pretty much the same story that we just did as well. Now, it's not about coffee, it's about flour and soybeans or something, right? Mm-hmm. Right, so to mix flour, a miller combines soybeans at 680 per bushel. Okay, so it's not per pound, it's per bushel, but you could say per pound if it made you, easy to understand. And wheat that costs $4 per bushel. How many bushels of each do you need so that you make 700 bushels costing $4.90 a bushel? In a lot of ways, isn't that very similar to the coffee question? Mm-hmm. Right, so I'm going to show you the coffee question on my left page, and I'm going to go over and do the bushel and wheat question on the right-hand side. Maybe when we see them side to side, we'll see how similar they are. So A is going to be what do they call it? Soybeans. So the soybeans, and I'll put the price in. There's $6.80 a bushel. And B, well, that's going to be, what do they call it? Wheat. And that's going to come out as $4 a bushel. And we know that you're going to get a total of 700 bushels, 700 pounds, and they're going to come in at $4.90 a bushel, right? So I don't know how many soybean bushels. I'm going to use X. I'm now going to figure out how much wheat there would be. Right now, when we had this story, wasn't the total that the two of them made 30?
Mm-hmm.
Right, in this case, the two of them make 700. So if this is X, this guy, the rest, the other stuff,
700
is
minus.
700 minus X, you see?
Mm-hmm.
And if the next story, it's 50 bushels or 50 pounds or 50 ounces, wouldn't you say X and 50 minus X?
Mm-hmm.
Right? Now, the total cost is going to be made up of $6.80 of this guy, plus $4, there we are, $4, I won't put in the zeros, times this guy. Can you see it's like 4 times X and 350 times that, right? 4 times X, 350 times that, 6.8X, gotcha,
Mm-hmm.
and 4 times that guy. Now, what do I know about the total cost? Well, 700 costing me $4.90. Well, if I just do that on my calculator, the total cost of 700 averaging at $4.90 is a huge number, 3430, right? Over $3,000. I now have my equation. 3,430 is this guy plus this guy. That would be the equivalent to this line here.
Mm-hmm.
Okay. Can you see where we're going to go from this point?
Yep.
And would you agree it's just bigger numbers? It's not any different. It's just awkward and big. Would you be comfortable you can finish that in your own time?
Yeah.
Right. Now,
the actual algebra, I don't struggle with. The biggest part that I struggle with is just finding the equation to solve.
Right. So if we can get to there, you're good to go.
Yeah. I have no problem with the actual solving. It's just the word problems like confuse me, and I get kind of like if all of the problems were just the equation, I would solve them all no problems. But they're
Gotcha.
making us find the equation, and that's what I have issues with.
They're a little bit easier now. They've seen a couple of this type. They keep changing the story, but for this type, the coffee, the bushel kind of story, are you comfortable about this?
Yeah, I think so.
Okay.
Do you think I could just try one real quick and see if I see where I get without?
Right. I'm trying to find another one that's similar to that, because the next bunch of questions actually
I think I have
change stories. Right. You got one. Yeah. Which one is it you're looking at?
To make a flour mix, the soybeans cost $7.90 per bushel. So
Okay.
790 per.
And what's the other one? The wheat, I guess.
The wheat is $4.50.
Okay, 50. And what was the total they asked for?
The total they want is $8.50 at $4.40 per bushel.
Okay, you want to try that?
Yeah.
I'll give you time, and you tell me when you're finished, and we'll go through. You'll tell me your lines, and I'll just go through them as you tell me.
Okay, so first thing I'm gonna do is, so they want $8.50 total, so it's gonna be $7.90 plus $4.50. No.
Not yet.
So I'm at the very first part.
Right. So what we need to do is figure out these two guys, right?
Mhm.
Now, the first one is the soybeans. Now, you don't know what that is, so we're going to call it X.
X, and then
And what's the next one going to be called? Based on your story, because this is 850 now, your story's changed.
it's going to be X minus 850
Or,
for the wheat,
or,
or 850 minus X.
okay, it's important that you get that the right way around, or else your question won't come out. Okay, now that we're there, are you comfortable about the next line?
Yeah, now I need to take 850 and I need to multiply it by 540 to get my total.
Right, is that 540 or 440? I might have misread what you said.
Mine is 540.
Okay, so I'll put 540 down.
So 850 times.
And there'll be some ridiculous number. I'm just checking. You tell me what you've got, and I'll agree if it's the same as me.
It's a 4,590.
Yeah, you nailed it. Right, where are we off to now?
So now I think I'm ready to form my equation.
I agree. What do you write down?
So I'm going to take 4,590 is equal to 790 x plus 450 times 850 minus x.
You nailed it. Yep. Are you comfortable? You could finish the equation from there.
Yeah, that I think that's pretty much all I had issues with. Is just once I have the equation, I'm in the clear.
Okay. Have you tried any of the later ones? Because they keep changing the story. That's how you do the bushel coffee kind of story, but the next ones are to do with cyclists and miles per hour and feet and things like that. Have you done any of those puzzles?
So I tried the airplane. The airplane one was giving me some trouble.
Okay.
The airplanes are 2,350 miles apart.
2000. Say that second number again.
2,350.
Gotcha.
And they're
how far apart?
traveling towards each other. One
Right.
plane is 80 miles faster than the other plane. The planes pass each other in 2.5 hours.
Okay. I don't know. I'm going to call this the slow one. And they pass each other at what, 2.5 hours?
2.5 hours.
Okay, so the two things that we need to find here are A, going to be the speed of the fast plane, and B, the speed of the slower plane. I'm giving them that label, and that's actually the labels that they've got. They're calling the first one the slower plane and the second one's the faster, so that's fine. We've got good labels. Now, I don't know what the speed of the slow plane is, so I'm going to call that X. What do I know about the speed of the fast one? Well, I don't know what it is, but I know it's 80 more.
Right. So it's almost like the same thing we did, except it's going to be 80 x plus 80, right?
Yeah, you're right.
It's 80 miles per hour faster. So we almost have our equation now. So wouldn't it be 2,000 or 20?
See, this is where the twist happens. Normally in the coffee and the soybean ones, we'd be doing what you were about to say, but this story is a little bit sneaky. Because we're not doing soybeans and it's not two things adding up to something. We have to incorporate that guy. And we also have to incorporate that guy. And along with these guys, the whole thing's going to come together. So I'm looking at this and I'm saying, okay, there's going to be some mysterious point. It doesn't need to be halfway, right? Where the two aircraft meet up, okay? And I know that the time was 2.5 hours for that to happen. Now, here's the next piece that's different. I'm going to call this the combined speed. Do you know if you're going at 40 miles an hour and you get hit by a car that's coming against you and it's doing 50 miles an hour, isn't that the equivalent of being crashing into a wall at 90 miles per hour? Can you see that? Right. So what we've got here is not that the aircraft are going to crash, but the combined speed of them is going to be the speed of the fast one plus the speed of the slow one. So the combined speed is going to be x plus 80, that guy's speed, plus x, that guy's speed. So the combined speed is going to be 2x plus 80. Are you happy about where the combined speed came from? You're adding the speed of the fast aircraft and the speed of the slow together, because that's essentially the total speed that they're traveling at.
So solve for x would be 40, right?
Well, if that was be equal to 0, it'd be probably negative 40, but we're still a little bit more to do. But we are going to use this.
That's right.
Now, I know that this distance in 2.5 hours. You see that? This distance in 2.5 hours, right? So if I wanted to do the distance that you would travel, the formula for distance is speed multiplied by the time. You remember that formula? Distance traveled, speed multiplied by time.
Mm-hmm.
And I know the distance traveled was 2,350. I know the combined speed is 2x plus 80. And the time was 2.5 hours. So there is my equation. A lot different than the other ones. In fact, I'd probably put that number now that I see it. Wouldn't it be nicer to have the number at the front? So the total distance traveled was 2,350. It took 2.5 hours to do that, traveling at a combined speed of 2x plus 80. That's the equation that we needed to solve. Now it looks quite different from the coffee story, right?
Mm-hmm.
Now, at this point here, we have an equation. So let's just take it a little bit further and see what the solution is. What would you do next?
Distribute.
Okay, so you get 5x plus, God in Himmel. No, I'm not doing that in my head. It's probably 200, but I don't want to check it. 2 times 80. Oh, it was 200. What do we do next?
Subtract 200 by both sides.
So that's pretty easy to do in my head.
2150, right?
Yeah. And then what would you do?
Subtract 5x by both sides.
Oh, rephrase that. Look
Divide,
again.
divide.
That's better.
Divide.
So 2150, and I'll divide it by 5, and the answer I get is 430. So I can now go back to my story. And my story was that x is 430. So the slow guy is going to be doing 430 because that's x miles per hour.
Mm-hmm.
And won't the fast guy be 80 more than that? So that would be 510 miles per hour. And now we've got our answers. Fast one 510, slow one 430.
Mm-hmm.
So not every puzzle that we've done, not every application has ended up being exactly the same as the other, right? Each one you got to look at it a little bit differently, right? We built this guy up. That part was very similar to the coffee and the wheat story, but how we used these things were quite different, because in this case it was to do with speed and distance. So we had to figure a way of combining these to get a combined speed. You do that simply by adding to get this guy. And now we can say, okay, you fly that time at this combined speed and it's equal to that. And that's where this equation came from.
Mm-hmm.
Okay, so what's next? What do you want to look at?
Let's see. There are a couple here giving me issues too. Oh, this one I got wrong.
Okay, which one is it?
It's an interest one, which was weird because I was doing good on it for a while, but it is
number.
For me, it's number 11.
Okay, and do you want to tell me your numbers? That way we can make sure that you can see what you might have done wrong in it. So this is an investment interesting thing, right?
Yep.
So
an,
what did you get?
so an investment club invested $7,000 at a simple interest rate of 4.5.
Okay.
How much additional money must be invested at an annual simple investment rate of 5.5 so that the total interest earned will be 4.8% of the total investment? And I got $21.
So the total should be, what was the total interest?
The total should be 4.8% of the total investment.
Okay. Oh, that's a good one. So I'm going to have two things. I got to call them. Right. So let's call the first one A, and the first one A is going to be the extra amount. So I'm talking about this one here at 5.5%. Right, and I don't know what that is, and I'm going to call it X. Okay. So I need to just find out how much money at 5.5%, and we've solved the puzzle. So let's see what information they do give us. This piece of information is actually just going to be a number. It's 7,000, right? That's fixed. It doesn't change. It's still 7,000, and it's at 4.5%. So if you do 7,000, which is that, and you multiply it by 4.5%, which is a decimal is 0.045, you find out that for this guy here, you get $315 interest. Okay. Now, if I asked you to calculate the total interest that you got, it would be made up of this amount, which is $315, plus the extra amount at 5.5%. Now, if you don't know how much that is, you can still figure out what 5.5% is. As a decimal, 5.5% is that guy. So 315 plus 5.5% of an unknown X, that is our interest, right? That's the total interest that we would get.
So where would we use the 4.8%?
Yeah, now that is a sneaky one as well. Because if I said to you, how much money is 4.8% being calculated over? The answer isn't 7,000 and the answer isn't X. It's actually both of them. So the 4.8% comes out over here. There's 4.8% of all the money being invested at that rate would be this guy. So we are looking at that equation. Do you see how sneaky they were? 4.8 over the total. The total is made up of this guy, 7,000, and this guy, X, 7,000 plus X at 4.5%. 7,000 plus X at 4.5. Now we've got this equation. We should be able to solve it, right?
Right.
Would you agree distributing?
Yeah, distribute, then combine like terms.
And all that fun stuff. So 0.048 times 7,000 gets me a really nice number. 336.
So I did that, and I think where I got the 21 from was I subtracted the 336 from the 315.
That looks good. I think what didn't happen is there was a little bit more to do. Right, so you're going to take 336 away from both sides. And what do you want to do next? Really, there are two ways to do it. They both will work, but you have to make sure that you're consistent. So what are you going to do to both sides here?
Would you take 315 away from both sides, or?
I probably would, but you know, that's just me. Right. So if you take 315 away from that, you do get 21, which you mentioned earlier. So you weren't that far away as far as the 21 bit was concerned. You just thought 21 was the answer, right? And it's going to take a little bit more work. So it's not going to be 21 when it's finished. It's going to be X equals something, but it won't be 21. I'm pretty sure of that. What would we do next?
Subtract 0.048 from 0.055.
Yeah, and I believe you get 0.007. But I don't trust my math at this time of night, so I'm going to do it in the calculator as a double check. 0.055, take away 0.048, and I was right. Okay. Now, what do I do to both sides?
Divide. You're going to
Right,
divide 0.007x.
Right, so 21 divided by 0.007 comes out as 3,000. Now, based on the storyline that's going here, would you agree 3,000 does seem reasonable concerning the numbers, right? 7,000, 3,000, pretty good fit, isn't it? It looks right.
Mm-hmm.
Doesn't 21 seem a little bit in the small size when you look at the other numbers?
Right. Yeah. I believe so.
Right, and you could double check it, couldn't you? Just go and say, okay, then 7,000 at this, another 3,000 at that. Does it give me the same thing as 10,000 at this price? And I bet you it would work.
Mm-hmm.
And that is the end of that question.
Yep, it was correct.
Good. Have we anything else to do?
Let me see. Oh, this one was tough.
Which number is it?
It's number 13.
Okay, so this is mixing gold.
Mm-hmm.
It's kind of like bank money, although it's gold and silver, whatever the alloys and so on. So let's get your numbers to work with then. So a goldsmith mixes how many grams and what percentage gold alloy?
10 grams at 60% gold alloy.
Okay, and then he has another bunch of gold, doesn't he?
Yep.
And how many grams of that is it?
60 grams of gold at a 25% gold alloy.
Okay. The question is then, what is the percentage concentration resulting from this alloy, right?
Mm-hmm.
So in a way, I could do this equation without actually doing an equation. I could solve the puzzle and tell you what you would get. So what I'm going to do is find out the amount of gold, pure gold, you would get out of each of these two, right? Let's see what the amount of gold you'd get from A. Well, 60% of 10 grams means that there is 60%, which is that guy as a decimal, times 10 grams. And that ends up being 6 grams. Are you happy about 60% of 10 grams gets you 6 grams of pure gold?
Mm-hmm.
Right. Now, if you do the other one, you're going to get 25% of that one. So 25% of 60 grams of an alloy, you end up getting 15 grams of pure gold out of that one. Right, so imagine you took the thing and you melted it down. You'd get 6 grams of gold and the rest would be, some metal you're not really worth worrying about, right, lead.
Mm-hmm.
And then if you did the other one, you get 15 grams of gold and some muck that you don't really have any value to. So the total amount of gold, when you look at both of these, is 21 grams. So far, so good?
Mm-hmm.
Now, what percentage is that? Well, to get a percentage, you know how much gold there is, 21. And you're going to get something on the bottom, and you're going to then multiply it by 100, because that's how you make things percentages. And all I need to do is figure out what was the total weight, not the gold or the other stuff, but everything. What's the total weight if you have 10 grams of this stuff and 60 grams of that stuff? What goes here?
70 grams.
Right. And as a percentage, we go to our calculator and we go 21 divided by 70, which is that guy, times 100, and you get a very nice, too good to be true, but it is true, 30%. So this is a 30% gold alloy. So if you had a little cauldron and you put the first, maybe it was rings into the barrel, and you put the other stuff, maybe it was bracelets, and you melted it all together, you've now got 70 grams of 30% gold alloy.
Oh. Is the butcher one, because the next one is number 14, it's the butcher one. That's the same type of question, right?
The butcher one, looking at that, let's see. Yeah, so much of this stuff and so much of that stuff. 8 pounds, how bad it is. Oh no, actually 14 is much more like the money question, where you've got so much invested at this percent and so much invested at that percent. So it won't come out as this. It will come out as a real equation. So do you want to give me your numbers for 14 and we'll set it up?
Okay.
And I'm going to call them A and B again.
Okay.
So what's the first hamburger meat?
So the first one is 24% fat.
Okay, and the other stuff?
The other is 15% fat.
And you're going to combine these, and he wants to make how many pounds of hamburger, and what fat level do they want?
He wants 90 pounds of a hamburger that's 22% fat.
Did you say 22%?
Yes, sir.
Okay. Now I want you to, actually this in a way also kind of looks like a coffee question to me. Now, I don't know how much of this there's going to be, so I'm going to call it X. I know that there's going to be 90 pounds of it, so won't this one be 90 take away X? Doesn't that look very like the coffee story?
Yeah.
Right.
So
and now,
would I multiply the 90 by the 0.22?
You do indeed. So let's do that calculation so we can have a number to work with. So 90%, that's 0.90.
So what does that number represent? Does that number represent the total number of the fat percentage for the meat?
Not so much a percentage. It's actually, if you took it and you separated it from the meat to the fat, this number you're going to get is how much fat you would have in total. So let's figure out what 22% is. 0.22 times 90 pound. You would end up getting 19.8 pounds of fat. And the other 70.2% would be pure beef, nothing, no fat at all. So that number is just the amount of fat, not the percentage of fat, but just the amount of fat. And it's the amount of fat you would get from 22% fat and 19 pounds of the stuff.
So are you going to use that as your total? So are you going to use 19.8 equals X plus 90 minus X?
No, quite. You also have to factor this in, don't you? So it won't just be X, it'll be 24% X.
Oh, equals 24. I see. X plus. So the equation formation was right. I just had the numbers confused.
Okay. Does that look relatively simple? You've got equations like this before.
Yeah.
Distribute, combine like terms, and do all your stuff. Right?
Yeah, I can take it from there. Absolutely.
Okay. Okay. Did we get any more to do?
Let me see what else. I just have one last one, and then after that, that's it.
Cool. What's your question?
So it's going to be number 12.
And number 12 is a chemist story, right? Okay, so you give me your numbers again.
So a chemist has 4 liters of a solution that contains 0.36 liters of acetic acid.
Okay.
So the 4 contains 0.36. And
did you say 0.36?
Yes, sir.
Okay. And what else did you get then?
The chemist needs to prepare 7 liters of a solution with the same percent concentration of acetic acid. How much acidic acid must the 7-liter solution contain?
Ooh, that is a weird question. So he wants to produce 7 liters, the same percentage as that, and we want to know how much pure acidic acid, because that's how you're going to make it.
So wouldn't you, do you even need an equation for this one? Wouldn't you just multiply the 0.36 by 7?
That's interesting. I'm trying to think of why that wouldn't be a good. Oh, because it's not the same percentage. You're darn close to it, but it's not the same percentage. This number isn't a percentage, but I'm going to find out what percentage it is. And once I find out what this is as a percentage, then I'll do 7 liters times that guy. So we are going to do it in a kind of sort of the way you said. So 4 liters, 0.36 liters of it is pure acidic acid. Let's see what percentage that would be. So that would be 0.36 out of 4 times 100. So let's see what percentage that means. 0.36 divided by 4 times 100, and it ends up being 9%.
So now I would take the 9% and multiply it by
7 liters.
7 liters.
And I believe that gets you. Ooh, I don't like that answer, but I'll take it. It's 0.63 liters. So that's all you need.
Oh, that's it.
Check it, make sure.
6. Oh, it was correct.